Hi everyone. In this video, we are going to do L'Hopital's rule. So as always, we're just going to hop straight into it. So we want to find the limit of the following function as it's approaching 1, and we can't plug in 1 right away since that will lead to an indeterminate form. So what we want to do is we want to take the derivatives of the numerator and the denominator. Starting with the numerator, derivative of natural log x would just be 1 over x, and the derivative of x minus 1 would just be 1. And now we are in a good state where we could plug in 1, which would get us 1 over 1 over 1. And then this would just simplify down to just 1. And this will be our final answer. That one wasn't too bad, but we're going to do a few more examples in this video. Here's another simple problem you could try. Feel free to pause the video and attempt this yourself. So we want to find the limit of the following function as it approaches infinity. Plugging infinity in right away, we would get infinity over infinity, which isn't good. So we want to use L'Hopital's rule. And we want to take the derivative of the top and bottom, numerator and denominator. Taking the derivative of the numerator, it would just be e to the x. Derivative of the denominator would just be 2. And now we could plug in infinity, e to infinity over 2. And this right here would actually equal infinity. And this would be the final answer. Okay, so maybe these problems I'm starting off with are a bit too easy, but hey, who knows? But we're just going to continue moving along with the video. Let's try a rational function here. As always, let's take the derivative of the numerator and the denominator. Derivative of the numerator would just be 6x, and the derivative of the denominator would just be 10x plus 7. We're going to take the derivative of the numerator again, or you could just factor out x, but me personally, I like to take the derivative of the function again. So derivative of the numerator would just be 6. Derivative of the denominator would be 10. And we can simplify this function down to 3/5. And this right here would be our final answer. One thing to note is, look at the function. Notice how both the numerator and the denominator have a degree at most 2, and if we look at those terms with x squared, you notice that we have a 3 here and a 5 here, and we have 3 over 5 as our final answer. So if you want a quick way around it, just look at these two terms, but just make sure they have the same degree at most. So without any further ado, let's move on to the next problem. Hopefully I explained that part well. I don't know. Let me know if I did. Let's try working with trig functions now. Feel free to pause the video and attempt this yourself. Okay, so as always, we want to take the derivative of the numerator and the denominator, and this time we could apply chain rule. Taking the derivative of the numerator, we get 7. Oh my god. Why does it always do that? Okay, 7 cosine 7x over the derivative of the denominator, which is 4 cosine 4x. And now we could plug in 0. So 7 times cosine 0 over 4 cosine 0. Now, what does cosine 0 evaluate to? It evaluates to 1. So 7 times cosine 0, 7. 4 times cosine 0 equals 4. And this right here would be our final answer. The limit of this function as it approaches 0 is 7/4. So if you were able to do this, good job. If not, that is okay. We are going to do a few more. Let's try this function now. As always, we want to take the derivative of the numerator and the denominator, starting with natural log 4x. That would just simply equal 1 over x applying chain rule. And derivative of the denominator would just be 2x. And applying keep change flip to this, we would actually get 1 over 2x squared. And now we could plug in infinity, and plugging in infinity into the denominator, it would just get us 0, and 1 over 0 would just equal 0. And this is our final answer. Any constant over infinity will always equal 0. So remember that, and we will move on to the last problem. Let's top it off with yet another simple L'Hopital rule problem that you can attempt yourself before you hit resume on the video. So starting with the numerator, for taking the derivative, we would simply get cosine x minus 1 over 3x squared, derivative of the denominator. Okay, can we plug in 0 here? If we plug in 0 now, we would get 1 minus 1 for the denominator. No, numerator, not denominator. We would get 0 anyway for the denominator. So we would have to apply L'Hopital's rule again. So doing this, taking the derivative of the numerator, we would get negative sine x, just negative sine x over 6x. Okay, we still cannot plug in 0 as we would get 0 over 0 again. So we would have to apply L'Hopital rule once more. So taking the derivative of the numerator, we get negative cosine x over 6. Okay, now we can plug in 0, which we would get negative 1 over 6. And this right here would be our final answer, negative 1/6. Alrighty, that's going to be all for this video. I really hope you enjoyed or learned something from it, and if you did, feel free to like, subscribe, and hit that bell. I know this video was pretty easy if you're taking calculus right now, but if you're new to this type of math, hopefully this is a good introduction to L'Hopital's rule. As hey, it's the holidays, I want to make things easy. And please feel free to let me know what type of feedback you have in the comments, whether it's positive or constructive. That's going to be all from me, and I will see you in the next one, and happy holidays.